Hey guys, we're going to start chapter 10 here. All right. And so, chapter 10 is nuclear chemistry. And this is going to be important for you guys, for anybody going into nursing who might be working with radiation or going into radiology or dentistry. A lot of different areas use nuclear chemistry. So, we're going to kind of talk about the bare bones basics here. All right. And so, here, what we have is kind of like just some vocab, all right? Slide number 2, nuclear reactions. Here we have a change in the nucleus of an atom, so we're changing what element we're dealing with. And these real tiny changes actually can be harnessed in a lot of different ways, and they're pretty cool. So isotopes, isotopes have the same number of protons but different number of neutrons. And so if we look at the atomic number, that's your number of protons or your identification on the periodic table. So like hydrogen is element number 1. It's got 1 proton. Helium's element number 2. It's got 2 protons. The mass number is the number of protons plus neutrons. Electrons are so light that we don't count them when we're just trying to get a general idea of what the mass is. And so all we have is protons and neutrons, and they're, relatively speaking, fairly heavy, whereas an electron is extremely light. And the only thing that neutrons do, they don't have a charge, is they affect mass. And so here I've written down 4 isotopes of bromine. Bromine 75, 77, 79, 81. This particular set of isotopes are all odd numbers. That is not the case all the time. But you can see here in the notes right here, bromine, bromine, bromine. Here are all the numbers. If you look at bromine on the periodic table, it's atomic number 35. It's 35 on the periodic table. That's the number of protons. So boom, 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 boom. They all have 35 protons. Where things change is the mass number. All right. So here the mass number is 75. All right. And that's protons plus neutrons. And we can all do this simple math, right? If we're trying to get to 75, there's 35 protons. There must be 40 neutrons. And this right here is the symbol. Br is the symbol for bromine. It's got 35 protons, and this top number there, that's 75, that's the mass number. And you can see that trend continues down here for these 3 other isotopes. So for bromine 77, 35 protons, 42 neutrons, etc. You guys can handle this, all right? The number of neutrons determines the stability of the nucleus, all right? So uranium is another example. There's 2 isotopes of uranium, uranium-238 and 235. Uranium-235 is extremely unstable. That's what you'd use in a nuclear reactor. Uranium-238, it's a great paperweight, but it doesn't undergo nuclear fission or anything like that. Speaking of uranium, all right, we can start talking about types of radiation. We're going to have, these are 4 types of radiation. There's a lot of them. These are kind of the 4 major ones. Alpha radiation is just a helium nucleus, has a +2 charge. Beta radiation is a high-speed electron, so it's just an electron, but it is screaming through space. A positron is an anti-electron, which is kind of weird. If a positron and an electron run into each other, they get annihilated, and that can release even more energy. And then gamma radiation. Gamma radiation is extremely powerful. It has no mass, sort of like light. Excuse me, it is a form of light. We just can't see it. So here, alpha radiation are symbols there. That little fish, that's your alpha symbol. It's got 2 protons and 2 neutrons, and that's it. So we can use these, the atomic number and the mass number. It's just helium nucleus. Beta radiation, our symbol for that is E for electron. And we get this -1 on the bottom. That's the charge of an electron, but it has no mass. There's no protons or neutrons. It does have a mass, but as far as approximation goes, close enough to 0. High-speed electron, positron, same as an electron. And then gamma radiation is just very, very high energy light, like super duper high energy. It can be extremely dangerous.